Now suppose there are two objects are there, PQ and P1Q1, and having the same size but kept at a different distance from on an eye is shown in the figure. See now here is P1Q1 and PQ. These both objects are kept there at different places from our eye. And at the angle, what happened there, when we are going to see any object kept in front of our eyes, that time here it's creating angle while we are observing that thing. Suppose this is a P1, PQ, and from here to here, one angle is formed. Okay, and that angle is there alpha. This angle is here alpha. So the angle is substituted by the PQ at I is larger than the beta. Beta means we are going to speak about the P1 QA here. So it will be formed there one angle when we are taking about it. So we'll get here one angle that is a beta, and you can see this. This angle is the bigger than this angle. Easily we are getting it. Okay. So from this we understood that one thing: how much object is further from our eyes, that much it will create the angle, and then its size depends on the distance of an object. Okay, it's getting on our retina when we are getting that image. When it's the distance is just shorter, that we will get their larger image or bigger. And when they are smaller, means it is from distance. Suppose here it was just 25 centimeter, and here it was there 10 meter. So its size will be there smaller than the as compared to this one. Okay, so apparent size of an object is always depends on the distance of the object from the eyelids. Okay. Now we are going to see why do we have to bring a small object near the eyes in order to see it clearly. What is the reason behind it? Anybody can tell me? Why do we have to bring a small object near the eyes in order to see it clearly? When very small objects are there, then it's not possible to our eye lens that sunlight rays whatever reflecting from that object. It's not reaching up until the eye, and at times it's impossible to us identify which object is there. So due to that reason, we have to take it closer to our eye, and then we can see it clearly. Okay, now use of concave lenses. So we have seen already use of concave lenses, that is a medical equipment, scanner, CD player. Okay, these instruments use laser light for proper working of these equipments. Concave lenses are used. Then the peephole indoor. If you see there, as a CCTV camera, we are using this. Yeah, peephole on the door. So this is a small safety device which helps us see a large area outside the door, and this uses one or more concave lenses, which we are using that lens for watching from our home, from inside to the outside. That is made up from this concave lens, and which can cover their large distance. Can cover the large distance. Then next one is the spectacles. Now you can see that concave lenses are used in the spectacles for correcting the nearsightedness, and concave lenses are used for correcting the farsightedness. Okay, so convex lenses, convex lens is used for correcting the farsightedness, and concave lens is used for the correcting nearsightedness. Okay, so why is it used? We have learned about it already. So first we will speak about concave lens. The concave lens, what it's doing, it's diverging the refracting rays or light rays on it, and due to that reason it can create a proper angle and our eye can identify the image. Otherwise, it's not possible to us. Okay. Then torch, you could see the concave lens. What is the function of concave? That is the diverge from its own place. So it is a diverging from place. So due to that reason, these concave lenses are used. Concave lenses are used in the torch. What is the purpose behind it? That purpose is to spread the light widely. Okay, to spread light widely, and light can produce a small bulb inside the torch. Now, camera, telescope, and microscope, these instruments mainly use convex lenses. See that. Where is the convex lens is used? Camera, telescope, and microscope. To get good quality image, a concave lens is used in front of eyepiece or inside it, where it is kept front of eyepiece or inside in it. Now we are going to see the first one, simple microscope. Have you seen the simple microscope? Yes or no? Anybody can tell me? Have you seen? So now we are going to speak about the simple microscope. We have seen one video.
The microscope is a device which is used to view very small objects that cannot be seen with the naked eye. There are many types of microscopes, such as simple microscope, compound microscope, electron microscope, etc. A simple microscope uses the principle of a magnifying lens or reading glass. A simple microscope
Have you seen this convex lens? Yes or no? Now, front of your eye.
Yes, sir.
Yes, this convex lens is there, and this is used as a simple microscope. And through this simple microscope, we are getting image bigger than the original image, and it's near about or more perfectly. We can say 20 times larger image than its original size.
consists of a convex lens of short focal length mounted on a plastic or metal holder as shown here.
Now, it's and working of the simple
Principle
microscope.
and working of a simple microscope. When an object is placed between the principal focus and the optical center of a convex lens, a virtual, erect, and magnified image is formed.
Virtual means you know that it's not a real image, but we can see that image, and it is there erect. It is not inverted. See that whatever it is there erect image is there. Erect image means we are getting that as it is image. Okay, and it's getting there regular more than its regular size 20 times.
The ray diagram given here explains how an object looks enlarged when viewed through a biconvex lens.
Now here suppose if you see this BA is the object is kept there front of this your convex lens, and when we are going to through under or with the help of this simple microscope, then what happens? This image will be formed here. You can see, and we are getting there image that is the magnified image than the original. Means magnified is larger size than the original.
Observe that the object and the image are on the same side of the lens. Image is formed at the least distance of distinct vision from the eye. That is, the distance from the object is approximately equal to 25 centimeters. Magnifying power. The magnifying power M of a simple microscope is given by the relation M is equal to D by N, where D is the least distance of distinct vision and F is the focal length of the lens.
Here least distance means it is we are seeing that near point of our eye, that is at 25 centimeter. Okay.
From this equation, it is obvious that to increase the magnifying power of a simple microscope or magnifying glass, the focal length of the convex lens.
So from this figure, maybe you got the idea about the simple microscope. Any doubt? How one should see in this compound microscope? Can you tell me? Okay, once again, I think I have to show you one video. Just in this last video also we have seen about the microscope, their types. First one is their simple microscope, second one is their compound microscope, and third one is their your electron microscope. Now, when we are going to speak about the compound microscope, we have to consider there about the simple microscope something it is observed or it is used to observe the small side objects, and so but some minor objects like cells, our blood cells, then we can see their viruses, bacteria, which is unable to observe under these simple microscopes. So due to that reason, we have to use their compound microscope, and this compound microscope is used to study of these smallest objects which we can't see by our naked eyes. Okay, so compound microscope is made up of two convex lens we have seen, Simple microscope is made from the one only single convex lens. And here this objective has the smaller cross section and smaller focal length. So what happened here? We are using the two convex lenses, and at when we are observing this figure under the compound microscope, that time we are getting the two images. Means that two lenses we are using. One lens is their eyepiece, and one is their objective lens. It will see there. Okay, and so eyepiece is a bigger cross section, and its focal length is also larger than that of the object. Due to that reason, their higher magnification will be happen, and we can see. If you see here, this object is very small with the object this, and here you can see. Here we'll get it a larger. See, image is where this is your image. Okay, so this is your objective lens is here. Suppose this objective lens, and then this is the eyepiece. When this objective lens it observed here, but from objective lens, then due to this eyepiece, it will be create here one larger image, and we can see it. Okay, and the axis of both lines are the same in line. Okay, and if you see here compound microscope, it is there between this objective lens and this eyepiece, there is a hollow tube like structure is there. Okay, now we are going to see there one video about it.
To learn about the construction and working of a compound microscope. A compound microscope has multiple lenses which collect light from the object and then focus the light into the eye. These microscopes have the ability to magnify very minute objects to a substantial size, clearly showing the smallest details.
Might be you have seen this in our science lab. I think I also shown you when you were in 7th standard. It's compound microscope. Then those very or 8th standard that teachers also shown you the same thing. So compound microscope we have already seen, but how it's working, how that lens is, that all things we are able to see in this video. Okay.
There are three major parts to the compound microscope: a body tube, an objective lens, and an eyepiece. The body tube is comprised of two smaller telescoping.
You can see here, this is a body tube here. Okay, and this above you can see. So it is here your eye lens will be there, and if you see this is the objective lens where we are adjusting this objective lens according to that what are their objects we are going to keep under this microscope. So these are as per our need, we are going to use this out of three any lenses. Okay.
Tubes with lenses coaxially mounted at either end. The wider tube holds the objective lens, while the narrow tube holds the eyepiece. The knobs for both coarse and fine adjustment allow the tubes to slide 1 inch.
So here you are getting these two knobs. So by these knobs we can adjust according to our object distance, how much we want. We can adjust this our distance between the objective lens and the eye lens. Okay. If you take it closer, then we'll get a proper view. So this adjusting why? Because sometimes as it is where we have adjusted, will not get the clear image. So due to that, to getting the clear image, to adjusting the cross section area, we have to adjust with the knob. Okay.
Into another, varying the distance between the two lenses. The lenses are convex with different focal lengths. The lens closer to the object is the objective and has a short focal length, FO, usually below 1 centimeter. The lens nearer the eye is the eyepiece. Although the eyepiece also has a short focal length, FE, it is still greater than the focal length of the objective. A revolving nosepiece, known as a turret, is attached to the lower end of the objective. The turret can be rotated to change the power magnification as necessary. Below the objective sits a flat platform known as the stage. On the surface of the stage, two stage clips hold the slide in place. A small aperture is present in the stage, allowing light into the body. The body tube is arranged on an arm which is connected to a strong base. This arm allows the body of the microscope to tilt. A small mirror at the base of the microscope reflects the light through the stage aperture. Above the mirror, an iris, also known as a diaphragm, is present. Iris helps in controlling the amount of light passing into the stage aperture. Working of the compound microscope. The object O is placed just outside FO, the focus of the objective lens. A real, inverted and magnified image, I1, is formed. The magnified image, I1, acts as an object for the eye lens. The eyepiece is adjusted such that the image I1.
Now, here suppose this object is kept and which is through we have seen through this our objective lens. Then what happens between this gap is there hollow tube is there in it. Is create an image that is I1. So this is I1, this is I1. And from this I1, then it's reflecting due to this and we will get another image. Okay. Means when we are observing under the this compound microscope, we are not getting that primary image, we are getting the secondary image. Okay.
Lies within the focus of the eyepiece, FE. The eyepiece functions as a magnifying glass and forms a virtual, erect, and magnified image, I2, of the object. Magnification of the compound microscope. The magnifying power of a lens is expressed in diameters. A lens magnifying an object 5 times has a magnification of 5 diameters and is written as 5x.
So if you observe there on the compound microscope, there on that lenses where we are going to adjust, the return is 10 times, 100 times like this. Okay, depends on our adjustment we are taking it, 9x. So it's yet more than 9 times. If suppose that this image is 1 only, then we are getting the 9 times is multiple of 9. If we are getting the 10 times, it is this, we are getting the 10 times. Okay.
Magnification of a compound microscope is the product of the magnifying power of the objective and the magnifying power of the eyepiece. For example, if the objective has a magnification of 40x and that of the eyepiece is 10x, then the magnifying power of the microscope is 400x.
So by this example, might be you have understood how this magnifying power we are calculating. Okay. So if I think anybody is not getting it, so just I'm going to take it once again.
So the eyepiece is 10x, has a magnification of 40x, and that of the eyepiece is 10x, then the magnifying power of the microscope is 400x.
Okay, so like this, we have got here information about the compound microscope. Now, now we have to see the next thing, that is our telescope, and telescope also it is present in our school. If you want to see, you can come and you can watch it. Okay, we are going to adjust it. Last year we have adjusted. It's impossible to show you, but when school will reopen that time, definitely will show you. So now telescope, we know that this telescope is used for observing the distinct object like as distance object, like as the stars, like as a those are their planets, and so many things are there we can observe under this telescope. And this is used for the maximum observe astronomical sources. And due to that reason, this telescope is called astronomical telescopes also. In these also two types are there. One is the refracting telescope and second one is the reflecting telescope. So refracting telescope uses lenses, and Reflecting telescope uses their mirror and also lenses. Both are used in it. So its function and there are things we are going to see tomorrow. Okay. About the in both the cases, one is the first one, the refracting telescope, this uses lenses. It is a in image is formed at by the object who acts as the object and eyepiece which form the final image. So, like as we have seen in the compound microscope, same here, there are two lenses, two mirrors are there. So that is the objective lens, it's formed that objective image and eye lens there we are getting the which is the that final image. Okay, at eyepiece we are watching through it, we are getting their actual image. Okay, and this image whatever there through the telescope maximum of why you will see there between these two, this eyepiece and objective lens, there is a big distance. If you see in the telescope, that is the distance between it they are more. Why? Because it can adjust there, or it can take their absorb their maximum amount of light coming from the distant object. It will be corrected through it. So detected when it is correcting, then we can see that through the eyepiece we'll get the larger image than the whatever produced on the objective lens. Okay, so if you see there, one more thing, their objective lens is there bigger than the our eyepiece lens. Okay, so both lenses have their difference between its focal length also, as well as its size also. And both the lenses are fitted inside the, we have seen there, they are both are adjusted in the some metallic hollow pipe-like structure is there. It's not like that only very small distance. There are big distance between these two lenses, and their principal axis are the both same on the lines. The lenses are there, and this is used for different purposes, because when we have to observe some astronomical things, ज्यावेळेस आपल्याला काही प्लॅनेट्स वगैरे किंवा यांचं ऑब्झर्वेशन करायचं असतं, त्यावेळेस आपण काय करतो, टेलिस्कोपचा यूज करतो. कंपाऊंड मायक्रोस्कोपचा यूज आपण कशासाठी, बॅक्टेरिया, व्हायरसेस किंवा जे काही तुमच्या ब्लड सेल्स असतील यांच्या ऑब्झर्वेशनसाठी वापरतो. आणि सिंपल मायक्रोस्कोप म्हणजे छोट्या मोठ्या गोष्टी असतात त्या आपल्या समोर असतात. तुम्ही जर बघितलं, हे जे वॉच रिपेअर्स वगैरे लोकांकडे असतात त्यांच्याकडे बऱ्यापैकी सिंपल मायक्रोस्कोप असतो. ओके, काही जणांकडे कंपाऊंड मायक्रोस्कोप पण असतात. आणि हा जो थर्ड आहे टेलिस्कोप, हा थर्ड टेलिस्कोप हा बऱ्याच वेळेस हा ॲस्ट्रॉनॉमर्स वापरतात. घरगुती कोणी वापरत नाही, तर स्कूल्स किंवा कॉलेजेस यांच्याकडे असतात. ओके, so now optical instruments, their spectacles, we know that. So what is their conic lenses are used in various other optical instruments like camera, projectors, spectrograph. Okay, where is it used? In the camera, projector and spectrograph. And you will see their spectacles, their convex lens as well as both concave lens are used. Okay, but convex lens is used maximum time for the correcting farsightedness. Remember this, for correcting the farsightedness, and concave lens is used for the correcting the nearsightedness. Okay. Now we have to see their persistence of vision. What is the persistence of vision? Very simple. So we can see the any object. Yesterday only we learn its image is formed on our screen of eye, that is called the retina, and the image on the retina is long as the object is the in front of us. The image disappears when object is kept away from our eyes, or we went away from it, and this image is remain on our eyes just only for 1/16 second. Then afterwards automatically it will be removed if object is not present in front of our eyes. जर आपल्या डोळ्यासमोर कुठले ऑब्जेक्ट ठेवला तर इमेज आपल्याला दिसते, परंतु जर तो ऑब्जेक्ट आपल्या डोळ्यापासून साईडला गेला तर सेकंदाचा 16वा भाग 1/16 याच्या एवढ्या वेळेत तो काय जातो, डोळ्याच्या याच्यापासून डिसअपिअर होऊन जातो. आणि द सेन्सेशन ऑफ दिस परसिस्ट फॉर अ वाईल, हा जेवढा सेकंड टाइम आहे 1/16, एवढा जो टायमिंग पिरियड आहे याला काय म्हणतात तर परसिस्टन्स ऑफ विजन म्हणतात. काय म्हणतात तर persistence of vision. This is called the persistence of vision. Okay, now how do we perceive different colors? Now retina on our eyes, we have spoken already, their sensitive cells are present, and these cells are two types of their present, that is a one rod like structure and one is the cone like structure. So when rod like cells respond to the intensity of light and give information about the brightness or dimness of an object on the brain, and the conical cells means that is the cone shaped cells that respond to the color and give the information about color. See, rod like structure, they are the intensity of light and give the information about the brightness or dimness. Light is bright or dim, we can observe by that red cells which is present on our retina, that is the sensitive cells are present, and cone cells They respond to the color, and they will give the information about the color to our brain. And brain then processes all the information received, and we can see the actual image of the object. Then one more thing, the rod-like cells respond to the faint light also, but conical cells do not. See that why we are not getting the in dark different colors. म्हणजे रात्रीच्या वेळेस किंवा अंधारामध्ये आपल्याला कलर आयडेंटिफाय होतो. त्याचं कारण काय होतं की ह्या ज्या तुमच्या रॉड लाईक सेल्स आहे ज्याच्यावर ब्राईटनेस आणि डिमनेस याचं जे ऑब्झर्व केलं जातं किंवा त्याची इन्फॉर्मेशन घेतली जाते त्या सेल्स ऍक्टिव्ह असतात. परंतु ज्या तुमच्या कोनिकल सेल्स आहे त्यावेळेस त्या ऍक्टिव्ह नसतात, त्यांना ते कुठल्या प्रकारचा रिस्पॉन्स करत नाही. दस वी परसीव्ह कलर्स ओनली इन ब्राईट लाईट. The conical cells can respond differently to red, green, and blue colors. You know very well. These conical cells also they behave differently. They show the response different for red, green, and blue colors. So when red color falls on our eyes, what happens? The cells responding to red light get excited more than those responding. What happened? Red light. We are getting there more. Why? Because our these red cells excited for responding it, and we get the sensation of red color. And due to that reason, some people, those having their lacking of the conical cells, they are lacking to we can say identify the colors, which colors are represented of their eyes, and these persons are said to be the color blind. These persons are said to be the color blind, and apart from these, they distinguish between the different colors. Their eyesight is normal, means they are unable to see the colors or identify the colors immediately, but they can see our objects normal. So like this, today we have completed our lesson. Okay, if anybody is having any doubt, you can ask me. Anybody is having doubt? Yes or no?
No,